In this lesson, I want us to look at mathematics. Right, a common test written in September. And I want us to have a discussion on this. It was written in 1.5 hours, 75 marks. We take a look at the questions. These questions were done yesterday on financial mathematics, but your network was not good. And I want us to recap on this before we move on to the other questions. Edward bought a car for 150,000 Rand. The value of the car will depreciate at 8.4% per year. Calculate the book value of the car in 10 years' time if depreciation is calculated using the straight line method. Right, so you remember we had a look at this yesterday, and we took note of the fact that the straight line method has two formulae. The first one is P1 minus IN. This determines depreciation. Right, this determines depreciation. Simultaneously, we have appreciation as well, or growth in value, which is actually shown by the formula with a plus, and you saw that yesterday. Okay, this question was done, but I'll have to test and see if you're able to recall what was done yesterday than me just dishing out the answers. Choose the correct formula, which applies to the straight line method to solve the question. Okay. I'm giving you 2 minutes to determine the answer to 1.1. When Edward is said to have bought a car for 150,000, the value of the car will depreciate at 8.4% per year. Calculate the book value of the car in 10 years' time if depreciation is calculated using the straight line method. Can you do this now? I want to see what answer you're going to get before we discuss it together. And then you'll communicate your answer. And then you'll communicate your answer. Right, you'll communicate your answer.
Sir,
Yes, please.
24,000.
Well done, 24,000. Because you recall that we then said the Edward bought a car for 150,000. That is the principal. And it will depreciate at this rate, which we call the interest rate, I. Right. And so with that in mind, I'm excited that you're able to remember that we're going to use 1 minus IA. The principal is 150,000. The interest rate is 8.4%. You divide it by 100, you get 0.084. You multiply it by the number of the years, which is 10. And obviously, you're able to get actually exactly 24,000. Exactly 24,000. I want us to then look at the next question. I want us to look at the next question. Okay, it's a recap of yesterday's discussion. Your network wasn't so good. But there are more questions we actually will look at. Not only finance, but we're looking at this September test. Right, 1.1.2 is the reducing balance method. Please, I'm giving you 2 minutes to do this reducing balance method and share your answer. 2 minutes. Two minutes. Please let us know when you're done.
Sir,
Yes, please.
62,380.09.
Well done. So the reducing balance method is A P1 minus I to the nth power. The principal P at which Edward bought the car was actually exactly 150,000. 1 minus I, which is the interest rate, 8.4%, you divide it by 100, and you get 0.084, raise it to the number of the years, which is 10. And if you use your calculator, you got actually exactly 62,380 and 09 cents. That is the reducing balance method. Next question. The next question is about no Zippo. No Zippo invested 10,000 Rand for 3 years at an interest rate of X% per annum compounded monthly. The total amount of interest paid over the 3-year period was exactly 3,282 Rand and 71 cents. What was the total amount in the account at the end of the 3-year period? You have 1 minute. You have 1 minute. You have 1 minute. Right.
Sir,
Yes, please.
13,282.71.
Well done. So now we recall that to get the total amount is the present value together with the interest add. So the total is the present value plus the interest, 10,000. The interest is 3,282.71, and when you add everything here, you get exactly 13,282.71. Okay, so this is going to be the answer. So well done there. I'm glad you're able to get that one right. 1.1.2 is the next question. Calculate the value of X, the interest rate, for 5 marks. Can you try that one? The value of X, the interest rate. 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 Right. Let us know how far. Let us know how far. Right. Let us know how far. Right.
So,
Yes, please.
9.5%.
Okay, that's fine. I'm glad that you're able to get that one right. So it is actually exactly 9.5. 9.50%. But remember that to do this one, we use compound interest. 1 plus I, the nth power. 13,282.71. The present value is 10,000. The interest rate, because everything is compounded what? Monthly divided by 12. 12 multiplied by the number of the years, 3. Right, which is 13,282.71, which is exactly 10,000. 1 plus I of 12 raised to 36. So which means if we divide the board, we divide by 10,000. If we divide by 10,000, you'd have 13,282.71 divided by 10,000, which is exactly 1 plus I divided by 12 raised to 36. You want to solve for I, you take the 36th root. Right, the 36th root of 13,282.71 divided by 10,000. 1 plus I out of 12. I becomes, you subtract 1 multiplied by 12, so you'd have the 36th root of 13,282.71 divided by 10,000 minus 1. Right, we need to get the answer. For the sake of calculator practice, we'll determine it together. Right, to make sure we have a chance to look at how the calculator is operated. At this point, it is clear that we would take the number, we would punch the number 12, open bracket, and we'll punch in the general radical. Right, so you'd need a 12, open bracket, then a general radical, which is exactly this one here. Punching in a 36, and you have 13,282.71. You divide by 10,000. And you subtract 1. Close bracket. We get exactly this value here. This value is ordinarily multiplied by 100, giving us exactly 9.50%. 9.50%. 9.50%. We move to the next question. In the next question now, if we already know that this one here, the total amount, the X, we've got 9.50%. We've got the final amount of the total, which is P plus the interest rate, which gave us exactly 10,000 plus 3,000, right, 282 Rand, which became 13,282.71. I'm giving you 3 minutes or just 2 minutes to calculate the effective interest rate. Effective interest rate. You have 2 minutes. You have exactly 2 minutes to calculate the effective interest rate. Right. We continue. We continue. We continue. Right, so we continue. Please let us know when you're done by indicating the answer you got. By indicating the answer you obtained.
9.92%.
9.92%. Right, 9.92%. Okay. Right, well done. Great memory. 1 plus or effective is actually always, but always, the same as the following. 1 plus I nominal divided by m raised to the mth power, meaning we want to find the effective rate of interest or the effective interest rate. It is therefore 1 plus, we got the nominal before, and it became 9.50% divided by 100, it's 0.095. You divide by 12, and you raise it to the 12th power, you minus 1. Right, for the sake of calculator practice, we determine the rate together, which is open bracket 1 plus 0.095 divided by 12 raised to the power 12 minus 1. What is the answer? It's exactly this one here, but obviously we just multiplied by 100. So let's write it in 2 stages, which means the effective rate of interest is this one here. It is exactly 0.099. Right, 247.58. We multiply it by 100. The decimal point is going to move 2 places to the right. 1, 2, giving us 9.92%. This is the law of multiplication. I want to actually demonstrate with the calculator how this can be done. We take a look. We multiply the answer by 100, and what we achieve is 9.92%. And this is the interest rate. It is the effective interest rate because the 0.095 is something we call the nominal interest rate. Right, what we call the nominal interest rate. Nominal interest rate. Okay, now we continue with our search for answers. We continue with our search for answers. Right, we continue with our search for answers. Right, as we attempt to make sure that we understand exactly what is happening there. Right, dealing with the nominal interest rate together with the effective interest rate. I want us to look at the next question. Previn's grandmother gave him an amount of money as a gift. He opened a savings account and deposited the full amount into his account. The amount paid interest at the rate of 9% per annum compounded quarterly. He withdrew, Previn himself, 70,000 Rand from the account. So there was a withdrawal of 70,000 Rand. Now, the interest rate, actually is exactly 9%. We're going to divide that by 100. However, it is compounded quarterly. Previn withdrew 70,000 from the account 1 year after his initial deposit. At the end of the next year, the balance in the account was 72,838 Rand and 6 cents. Calculate how much money Previn received from his grandmother. Please try this question. You have 3 minutes. You have 3 minutes. You have 3 minutes. When you're done, please let us know. When you're done, please let us know. Right. Please let us know. Then we shall discuss the details of this finance question before we move on. Please let us know when you're done and the answer you got. Please let us know when you're done. Please let us know when you're done. Right, please let us know when you're done. Okay, then we're going to discuss so that you can understand the question. Maybe it's a long story. It might look like a long story and too complicated. Please let us know if you're afraid of the question or you think the question is too confusing. Please let us know so that we can know what you're thinking about it. If maybe you're like, okay, but this is too long, this is confusing, you let us know so that we can find a way to make sure that this question is understood. Please let us know. Please let us know.
Yeah, it's a bit confusing.
It's a bit confusing. Okay, that's fine, but yes. But note that we shall be using what? Compound interest to do this question because it's a compound interest calculation. And the terms are quarterly terms. And so it is therefore very important to ensure that we have a clear understanding of this particular question and can be able to make the kind of sense that is required here. Right. Okay. Let's just take a look at this question together. As we try and internalize it, then there are more questions that you're going to get today in the 2 hours that we shall spend together. Compound interest is A equals the present value 1 plus I to the nth power. This is compound interest. We note that Previn's grandmother gave him, so there's a timeline that we use. Right. But if Previn's grandmother gave him an amount of money as a gift, he opened a savings account and deposited the full amount into his account. The account paid interest at the rate of 9% per annum compounded quarterly. Compounded quarterly. He withdrew 70,000 rand from the account 1 year after his initial deposit. Okay, now, this is the story. So there's something called time 0 in the beginning, time 1, time 2, time 3, time 4. Every year, that is a year, has 4 quarters. Right, so every year has 4 quarters. You can divide every year into 4 equal segments, into 4 groups of 3 months each. Into 4 groups of 3 months each. So that now, what we then have here is that what is happening is Previn's grandmother gave him an amount of money as a gift. If the money is given, it's a present value. It's like a loan. They give you this amount of money. They give you P, present value. They give you all the money now. It is a present value. And what he does, he opens a savings account and deposits the full amount into a savings account. So Previn takes all this money, but He does not even remove 1 cent from the money, but like full amount. And the account paid interest at the rate of 9% per annum compounded quarterly. So this became 9%. And obviously, we're going to divide it by 4. He withdrew 70,000 rand from the account 1 year after his initial deposit. So 1 year, right, 1 year after his initial deposit, it means that he's going to count first quarter, second quarter, third quarter. You see, the first quarter is up to January, February, March. The next quarter is April, May, June, end of June. And so now you therefore have the quarter 1 of 3 months, quarter 2 of the next 3 months, 6 months, quarter 3, another 3 months, 9 months, quarter 4, another 3 months, giving us 12 months. This is it. So you are told that he withdrew 70,000 from the account 1 year after. So now we understand that here at time 0, there's going to be the first quarter. And suddenly it ends because you have when the money was given, then there's January, February, March. March is ending here. March is ending here, and that marks the end of the first quarter. The end of the second quarter. Right. So now the second quarter starts and it ends here. The end of the third quarter, the end of the fourth quarter, the end of the year. The end of the year, the fourth quarter. In other words, he then does what? He decides to, so he withdrew 70,000 from the account 1 year after his initial deposit. So in other words, this guy is going to subtract 70,000 from this. At the end of the next year, the balance in the account was what? This is it. At the end of the next year. So there was a year. Then there is T5. Then there is term 6. There is 7. Then there is T8. So now you need 4 quarters. So you're going to do this one like this. Then you count 1, 2, 3, 4. And this gives the end of year 2. End of year 2. All right. End of year 2. Now, at the end of the next year, which is year 2, the balance in the account was exactly 72,000 and that. Okay. So now to do this question, what we then do, we take the amount of money because they just put the money there, boom, in the savings account. And the money was just sitting there. But the money, because the savings account, the money was growing in value. So which means that present value, and then it grew. One plus 0.09. And then you divide this by 4. This amount of money is going to stay there, but it's going to stay there for a year. Right, it's going to stay there for 4 quarters, for a year. So you put 4 here. When the money has stayed there, after 1 year, he removes 70,000. He withdraws some of the money. And then, after withdrawing, we want to know at the end of the next year, the balance in the account was this. So there's 1 plus 0.09, you divide by 4. And you have the following. Right, we have the following. You have exactly the following. So now the next year means that it's going to stay for another 4 terms, another 4 quarters. It's going to stay for another what? Another 4 quarters for the next year. So now it is exactly the same as what? 72,838 rand and 6 cents. Right. So this is the amount of money there that's going to be there. So if we want to calculate the amount of money, we take the investment, we grow it for 1 year, we minus the withdrawal amount. The withdrawal amount, we minus it. And after we minus it, we leave it for another year. And therefore, we put an extra factor of compound interest. And then now we want to solve everything. So what we're going to do is that we're going to divide this one by that. $72,838.06 divided by 1 plus 0.09 and then plus 70,000. Now, what you then do, you divide it by this, and then you move the 70,000, and then now the present value, then you're going to divide by this one. Using the red color, you take 72,838.06. You divide it by 1 plus 0.09 divided by 4 to the end, to the 470,000. You divide everything by 1 plus 0.09 divided by 4 raised to that, and this is equal to, let's just use a calculator. Let us use a calculator. Division, 72,838.06. You divide by the following. 1 plus 0.09 divided by 4 raised to the 4th power plus 70,000 and then this is 0.09 divided by 4 close bracket raised to the 4th power. So this is actually exactly the following, 0.99999, etc. So is actually exactly 125,000. Exactly that. 125,000. 125,000. Any question? Anything you want to ask? Anything you do not understand about this question, Previn's question? Any challenges that you think you have about this question? Right.
No questions, sir.
Okay, we move on to the next one. Right, next we're looking at probability. Probability. The daily maximum temperature in degrees Celsius or degrees centigrade and wind speed in kilometers per hour for a city were recorded for a period of 1 year, 365 days. The data was summarized in the table below. Number of days the wind speed, number of days the wind speed was at least or greater equal to 15 kilometers every hour, 15 kilometers per hour. But the number of days the wind speed was less than 15 kilometers per hour. Number of days the maximum temperature was less than 25 degrees Celsius. Number of days the maximum temperature was at least 25 degrees Celsius. 139, 105, 87, 34. Use the information in this table to answer the questions below. Calculate the probability that the maximum temperature was at least 25 degrees Celsius on a monthly randomly selected date. Right, randomly selected date. Randomly selected date. So what are you supposed to do? Here you need to use, or rather calculate, because you need to use the information in this table to answer the questions that follow. Calculate the probability that the maximum temperature was greater or equal to 25 degrees Celsius on a randomly selected day. You have 2 minutes. You have exactly 2 minutes to do this question. Right. 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 So now, yes, please.
I said 105 plus 34, which is close to 139, over 360 is equals to 0.39.
Okay, good. Let us check what you are saying there. So the probability here, which means you're going to find the probability of temperature at least 25 degrees, which is 139 divided by the total period 365 days. And if you use a calculator, you'd get the following. You'd get exactly the following. Just use a calculator to check our calculation and see what we need to get here. So now if you're going to say, here is our calculator. So you're going to have 139 divided by 365, which is 0.38. 0.38, or yeah. So you're going to get 0.38. 0.38 is exactly the same as 38.08%. Any question? Any question? No question. Let's look at the next one. Calculate the probability that the maximum temperature was greater or equal to 25 degrees Celsius and the wind speed was greater or equal to 15 kilometers per hour on a randomly selected day for 2 marks. You have 2 minutes. You have 2 minutes. You have 2 minutes. You have exactly 2 minutes to do this question. You have exactly 2 minutes to do this question. Please let us know when you're done. Please let us know when you're done.
So,
Yes, please.
so,
Yes, please.
um, I said 105 over 360, which is 0.29, which gives me 29.17%.
Well done. So now at this point, you're aware that the probability of the temperature greater or equal to 25 degrees Celsius and wind speed greater or equal to 15 kilometers per hour. This would be the same as this one here, where the number of days maximum temperature was greater or equal to 25 degrees and this greater or equal to 15. You have exactly 105 divided by 365. And see, when you get the answer to these, you'd have 105. 105. Right, so you have 105. You divide by 365. And it is 0.29, 0.29 or 28.77. 0.29, or we can say it is actually exactly 28.77%. Okay, we move on to the next question. Move on to the next question. Are the daily maximum temperature and wind speed independent events? Motivate your answer by calculations. You have 3 minutes. You have 3 minutes for the 4 marks. Please let us know when you're done. And then we can see what to do, if you got it right or not. If you got it right or not. Right. Right. So we continue. Let us know when you're done with this question. Then we'll discuss exactly what needs to happen here. So we continue.
Specialist in the Northwest is pushing to break stereotypes that it's a difficult subject. Tebogo Mokoena, or Jobewa Maths, as he is affectionately crowned the best mathematics teacher in the country at the National Teachers Awards in 2022, says he wants to change the narrative that maths is a
So we continue.
course. It changes the name into a course. Or jogo dlala kaMethe sayinayithi tsenya course. So when
So we continue. So we continue. We continue. Let us know when you're done.
So may you please help? Yeah.
Okay, that's fine. Okay, too easy. Let's discuss together. Obviously, each time you must be given a chance to try the questions because it's the way to learn. 2.3, you must first determine the probability of wind speed. The probability of wind speed that is greater or equal to 15 kilometers per hour. Right, let us look at the probability of wind speed that is greater or equal to 15 kilometers per hour. So if you add this one and this one, 139 plus 105 is equal to what? 244. So you take 244, you divide by 365, and you get the answer. Using a calculator, it is actually exactly 0.67, like so. You simultaneously proceed to compute the following, that whenever now you are dealing with the probability of temperature that is at least 25 degrees Celsius, the probability of wind speed at least 15 kilometers per hour, then what is the probability of at least 25 degrees Celsius? We got it in the previous question and we got 0.38. Multiply the probability of at least, because you are dealing with the daily maximum temperatures and wind speed. So we are dealing with maximum temperature and also wind speed. Right, and so now we actually know the probability of wind speed that is maximum. Right, so obviously now that wind speed has probability of 0.67. Let us use a calculator to check the answer. you'll then be in a position to do the following. 0.38 times 0.67. It is 0.25. 0.25. Right. And so what is the observation here? In the previous question, we're able to get the probability of temperature at least 25. And the following. Right, and the following. So you have exactly the following. Right. Right. We continue. We continue. We continue. Right, we continue. So that in this case, then you have the temperature that is at least 25 degrees Celsius and wind speed. Right, now the wind speed. Right. We continue. So then you're going to have what? Temperature at least 25 degrees Celsius and wind speed at least 15 kilometers per hour. Right, so we analyze this. So you see, if you take these temperatures at least 25 degrees Celsius and the wind speeds that are at least 15 kilometers per hour, we look at the previous question. And we got that answer to be what? These temperatures at least 25 degrees Celsius and wind speed at least 15 kilometers per hour, we got 0.29. Right, so this one became 0.29. But this one, when you multiply them, the probability of temperature at least 25 degrees Celsius times the probability of wind speed at least 15 kilometers per hour. You will therefore have the product of these, which is 0.25. We can see that 0.29 compared to 0.25, these are not equal to each other. 0.29 is not equal to 0.25. And the conclusion, therefore, is that, therefore, the temperature on a specific on a specific day and the wind speed on the same day are not independent events, are not independent, are not independent events. These are not independent events. Right, these are not independent events. Right. Right. So we continue. We continue. Why they're not independent events? Because 0.29 is not equal to 0.25. So these are not equal to each other. If these were equal to each other, we'd be talking of what we call independent events. But obviously these are not such events. We move to the next question. 2.2 is about for two events A and B, it is given that the probability of A is 0.3, the probability of A and B is 0.2, the probability of not B is 0.25, where A and B are two different events. Draw a Venn diagram to actually represent this particular information. Draw a Venn diagram to represent this particular information. So what we're then having here is the following. Here is the Venn diagram. This is called the universal set. The probability of the entire sample space is 1. The probability of the event A, because events A and B, event A, event B, they intersect because the probability of A and B is 0.2. The probability of A alone is 0.3. So if the probability of A is 0.3, there's 0.2 here, so this is 0.1, so that 0.1 plus 0.2 is 0.3. The probability of not B, right, so and it is 0.25. Right, and so obviously now we will fill that in there, where A and B are two different events. So now the probability of not B can be determined as well. Because what would not B mean? So not B would mean everything that is not in B, but in the sample space. So which means, therefore, the probability of not B will take care of this particular region that is all over the place. Right, which is all over the place. And so the question would simultaneously then mean, what then is the probability of B? Right, and so to actually settle this question, we actually continue as follows. We're asking the questions. What probability is going to be put here outside A and B? And what probability is going to be put here in B? Right, so try this particular question and give us the answer. So now I'm going to call this one X, and I'm going to call this one Y. Right, so now tell us, in the Venn diagram case, what X is and what Y is. I want to see what you're going to do. X and Y. What is X? and what is Y? What is X and what is Y? Right, please let us know when you're done. Let us know when you are done. Let us know when you are done. Let us know when you are done. How far? What is X and what is Y? What is X and what is Y? Right. What is X and what is Y? Right. What is X and what is Y?
Okay, so
How far?
I don't know what I was doing, but I got the answers. I don't know if they're right.
Okay, what is X?
X is 0.1,
Okay, Y.
0.6.
Okay, that's fine because we are practicing here. The minute in the exam they tell you the probability of not B would mean this. If this is A and this is what? B. So this would mean A and B. A, B. Then when you talk about not B, would mean this. We shade not B. And that will be not B. not B. In the same way that, so you shade everything outside B. So you can have this one and that one for A and for B. Not A. This would be not A. So we shade like this, but this will be not A. So with this kind of understanding, we want to know the probability of, if it's not B, it means everything that is outside B must be 0.25. So it means that now there's already a 0.1. So you must then say, out of the 0.25, you subtract 0.1. Which is 0.25 minus 0.1, which is 0.15. Not 0.15, which means that X is 0.15. So that the probability of not B, everything outside B is going to be 0.1, 0.15. You add them together, you get 0.25. Now, what is then the probability of B? What is the probability of B? What is Y in the diagram? So what is Y in the diagram? What is Y in the diagram? Find Y. That is the exercise. We found X. Find Y in the diagram. That is the probability of only B. Only B. What would the probability of only B be in this case? Find the probability of only B. Y. What is Y in the diagram? I'm testing your skills to do probability calculations. This was written by grade 11s in KZN, but we are practicing and we will continue right into the week doing more provincial papers that were written in November and so on and so forth. But probability is there, part of your grade 11 curriculum, part of your final exams. This was a grade 11 paper, but obviously we're gonna do more papers. But find Y. This one, Y, that one. What is this? The probability of only B, what is it? The probability of only B, what is it? You have 2 minutes. I'm testing you. You'll forgive me that I'm testing you. Right. Right. I'm testing you. How far? How far? How far?
So
Yes, please.
I got 0.55. I don't know.
You got 0.55.
Is
Well done. That's correct.
okay.
So this one is 0.55. How did you get 0.55? Just curious because you got the correct answer.
Oh wow, so
Yes.
um I added all of them. I said 0.1 plus 0.2 plus 0.15 plus y is equals to 1.
Yes. And then it's solved for y. Well
Yes.
done. Correct. Well done. Well done. That is the correct way to do it. Okay. So you can then just say from 1 you minus. So y is equal to from 1 you minus 0.1, you minus 0.2, you minus 0.15. And then you'll see that y is 0.55, right? Because 1 is the probability of the whole sample space. All right, now let us move to the next question, right? Because it's very important to test you to see if you're sleeping or not, right? So we look at the next Venn diagram. We have the probability of the overall sample space is 1. Event A, event B. Event A and then event what? B. Not 0.2, not 0.1, not 0.55, not 0.5. Determine the probability of, this is the Venn diagram we just drew now. Determine the probability of A or B. What is the probability of A or B? 2 marks. You have 2 minutes. Then we shall discuss together. Right. You have 2 minutes. You have 2 minutes. What is the probability of A or B? You have 2 minutes. The probability of A or B. The probability of A or B. What is the probability of A or B? Please let us know when you're done. 2 marks. 2 minutes.
So
Yes, please.
I got 0.45.
You got 0.45. What did you do?
I used the rule, the addition rule of P, probability of A or B is equals to probability of A plus probability of B minus probability of A and B.
Well done. So the probability of A or B is actually the probability of A plus the probability of B minus the probability of what? Of A and B, yeah? Good. That is the addition rule. So that the probability of A or B is the probability of A. The probability of A is what? In other words, in this case, we can see the probability of A. What exactly is the probability of A? The probability of A is 0.3. And the probability of B is this one plus this one, 0.2 and 0.55 is the probability of B in the whole event. So now it's going to be 0.75 minus the probability of A and B. A and B is the intersection, and the probability there is 0.2. Right?
Oh, so I used the ones on the
On the
diagram. I said 0.1 plus 0.55.
Okay, good. Let's check that one. So the probability of A or B, it is correct to think that way. So you did 0.1 plus 0.55. What did you get as the answer if you sum the two?
I got 0.65.
0.65
Yes, and then I said minus 0.2.
minus 0.2. And you got
Yes.
0.45. Okay, that's fine. We're learning. It's not that we're going to decide whether to promote you or not based on this paper. You must also remember that your grade 11 marks are very important for entering to university. So this is not joke. It's your future, it's your life. So you need to go all out and make sure you become a go-getter. Right, so this is the answer. So the answer is 0.85. So it means therefore the probability of A or B is this one, which is 0.85. Okay, you did a small mistake in your calculation. What mistake did you do? The probability of A or B, we can use the numbers on the Venn diagram, yeah? Because if you look at these carefully, you can be in a position to think as follows. To then say the probability of A or B would be, so the probability of A or B is going to be, you can take the numbers, the probability of only A is 0.1. So this one is only A. And this one is what? Only B. And this one is what? A and B. So the probability of A or B would be exactly this one. So A or B, if in mathematics you say A or B, it means A, only A, which is 0.1, or B, which is 0.55, or both A and B, the intersection, which is 0.2. So you can just add this, that. Because the probability of A or B is either A or B or both. So now if you add everything, let's use a calculator to just make sure we get the correct answers. Make sure you get the correct answers. So now at this point, then what we're going to do, we're going to take our calculator and say we have 0.1 in blue color plus 0.2 in blue color plus 0.55 in blue color. What is the answer to this? 0.85. 0.85. So in other words, there is another addition rule we can use for this. What is the addition rule that we can use for this, Pechalelo? Right, we think clearly. If you want to find the probability of A or B, it is either A only A, or only B, or both A and B. And now you can just take the 0.1, 0.55, and then with the 0.2 add them up, and this is going to give us the probability of A or B. Or you use the addition rule. Right, you use what you call the addition rule. What is the addition rule? It's that the probability of A or B is the probability of A plus the probability of B minus the probability of the what? Of the intersection. Minus the probability of the what? Of the intersection. Any question on this one? Right. Okay, any question?
No, sir.
Okay, move on. Let's try the next one. Let us look at this one now about Sizwe. Let's answer the questions about Sizwe. Sizwe is enrolled with the driving school that guarantees that he will pass the test. So Sizwe wants to know how to drive cars. So what Sizwe is doing is that he goes to a driving school, and the driving school is guaranteeing that he will pass the test to obtain his driver's license. He's guaranteeing that he will pass the test to obtain his driver's license. The probability that he will pass the driving test on his first attempt is 2 out of 5. If he fails on his first attempt, the probability that Caesar will pass the test on any attempt in the future is 2 over 3. So either Caesar is going to pass the test, or he might not pass the test, he might fail the test. So those are the possible outcomes. Calculate the probability that Caesar will pass the test in 2 attempts. Calculate the probability that Caesar will pass the test in 2 attempts. You have 2 minutes. Then we'll discuss the corrections. Then we discuss the corrections. Right. You have 2 minutes. So we continue.
Lord Jesus Christ. Hallelujah. You are Lord and God of.
Right. Please let us know when you're done. How far, Pehelelo?
Sir, please help. I don't understand.
Okay, that's good. Because I thought it is a very simple question. Let us do the question like this. So we're going to use something we call a tree diagram to make sure that we can think clearly. The probability that he will pass the driving test on his first attempt. So there's going to be a first attempt. So in other words, Sizwe can just attempt, he's going to write the test for the first time. If he fails, then he's going to write again. On his first attempt, it is either he passes, it is either a pass or a what? Or a fail. But the probability that he will pass the driving test on his first attempt is 2 out of 5. Okay, 2 out of 5 is going to pass. But now, if the probability of failing is 3 out of 5, because if you add this and that, you must get 1. That is the total probability. So if they give you the probability of a pass is 2 out of 5, it means that you must say 1 minus 2 out of 5. And then you get 3 out of 5, which means that now it's 3 out of 5. 3 out of 5 is the probability of a fail. Okay. If he fails on his first attempt, okay, we are here. First attempt is a fail, right? If he fails on his first attempt, the probability that Sizwe will pass the test on any attempt in the future is 2/3. Is 2/3. So now, if he fails, then there's a chance that he can pass, or he can still fail again. Okay, so Sizwe can fail again. So now, this is it. If he fails on his first attempt, the probability that Sizwe will pass the test in the future, a pass is 2/3, which means a fail is 1/3, because when you add these things, you must get 1. Okay. Right. So we continue. We continue. So the probability that Sizwe will pass the test in 2 attempts, that is what we want. What is the probability that Sizwe will pass the test in 2 attempts? Right, so we will analyze that together. And this would therefore mean the following. We'll check this one and say the probability of passing on second attempt. Passing on second attempt. Passing on second attempt. Okay, so now, if it's going to pass on second attempt, then the probability of is that he's gonna fail first. So first is gonna we determine the probability of failing on first attempt. Failing on first attempt times the probability of failing, or rather passing second attempt, that is. Passing on second attempt. The probability of failing on first attempt. The probability of passing on second attempt. So he's going to pass second attempt. But when he passes the second attempt, he would have failed first. And therefore, the answer is 3 times 2. 6 out of 5 by 3 is 15. Divided by 3, 2 out of 5. And we have 0, 40. 0, 40. Any question? Any question? Any question? Any question?
No question.
Okay, good. In the absence of a question, we move on. Now, I want us to focus on this one. Our tree diagram is still there. The probability that you will pass the driving test on his first attempt. So you attempt for the first time and then there is a pass or there is a fail. All right. So now the probability that you will pass the driving test on his first attempt, the probability of a pass is 5 out of 3, and then the probability of 2 out of 5, and the probability of a fail. Okay, if they give the probability of a pass, you then say the total probability is 1 minus the probability of a pass, so that you take the LCD here, and then you say out of 1. 5 divided by 1 is 5 by 1, 5 minus 2, giving us 3 out of 5. So the probability of a fail is 3 out of 5. Now, if he fails on his first attempt, we continue with our investigation. He might fail. If he fails on his first attempt, the probability that Caesar will pass the test on any attempt in the future. Right. Obviously, in the future now, it's either still is going to pass or it's going to fail. We can't just say it's going to pass in the future. He might fail. But if he fails on his first attempt, the probability that Caesar will pass the test on any attempt in the future is 2/3. And then this one is 1/3. Calculate the probability that Caesar will pass the test in 3 attempts. This one is yours for 2 minutes. Calculate the probability that Caesar will pass the test in 3 attempts. Because now we can then say, in 3 attempts, it's yours. Over to you. Let me know, please, when you're done with it. Because the aim is not to spoon feed you, but we need to train you as a soldier. You are going to war. You are in the army. You need to practice. You need to be trained. You need to exercise your muscles. You must flex your muscles if you are to become the kind of a champion in war. But now we can't just let the soldier that is going to fight in war just chill and eat ice cream all the time and not train. You see, then we're like committing suicide, because the soldier, when they get to war, there the muscles are stiff. The muscles are stiff, and the soldier cannot do anything. And the enemy will be very delighted. That's what is happening there in Russia and Ukraine, because it is the same thing that is happening there. Okay. So this is it. This is it. Please let us know when you're done. Please let us know when you're done. Let us know when you're done.
So,
How far? Yes, please.
I got 8 over 5.
Okay, let us check. You got 8 out of 5. Okay, let us check this out together. So the probability that Caesar will pass in 3 attempts. For Caesar to pass in 3 attempts, he must fail and fail and then pass. So which means that now it's going to be like this. This is the tree diagram because this one is going to be in the future. So in the future, then the probabilities are going to be the same. The probability of passing in the future is 2 over 3, and that one is 1 over 3. So now we are dealing with 3 attempts here. So now the probability of Caesar, because now we must be realistic. Caesar must pass after 3 attempts. So he must fail twice. So now we're then saying with passing on 3rd attempt. Failing on 1st attempt. Failing on 2nd attempt. Failing on passing on 3rd attempt. Passing on 3rd attempt. So the probability of failing on 1st attempt, because for Caesar to pass in 3 attempts, he must fail. The probability of failing is what? The probability of failing is 3 out of 5. Then 2nd attempt, he fails, 1/3. 3rd attempt, he passes, 2/3. You multiply these things. So if you multiply these things now, because this is 3 out of 5. 3 out of 5. So 3 out of 5 means that this 3 is going to cancel out. And this is 2 divided by 5 by 3, 15. So which means that it's going to be 2 out of 15. But 2 out of 15, if you use a computer, calculator, you can get the decimal of this. Okay, you see, I'm just doing this so that you can compare with your answer. Because you see, every time I'm testing you.
I did a mistake. I added instead of multiplication.
Oh, I see.
Multiply.
Okay, that's fine. Because we're learning. It's not the exam yet. It is not the exam yet. It is still practice time. So this one is 0.13. 0. What? 0.13. So that is the answer. Because now 3 attempts, it means that he must fail, and then pass. Part of failing is 3 out of 5. Then he fails is 1/3, and then he passes 2/3, and then he gets his driver's details, and he gets his driver's license. He gets his driver's license. But now we're saying calculate the probability that he will pass the test in 4 or more attempts. in 4 or more attempts. Okay, you have this one. You have 2 minutes. You have 2 minutes. You have 2 minutes. Right, you have 2 minutes. We continue. We continue. We continue. How far?
I got 2/45.
Let's say, okay, that's fine because we're practicing. There's no train smash. We're going to deal with this. So to do that question, we're going to start like this. Either there's a pass or a fail. So the probability that you will pass, it's 2 out of 5. The probability of a fail is 3 out of 5. We saw that one, and we understand why that is the case. If he fails on his first attempt, the operator will pass the test on any attempt in the future. So you have a pass and a fail. The probability that Caesar will pass the test on his on any attempt in the future, it's 2/3. So the probability of failing is 1/3. And this will be the second attempt. The third attempt is the same thing. It's either he passes or either there's a pass or there's a fail. 2/3, 1/3. 4 attempts. All right, so this means that the probability of this means that the probability of passing on 4th attempt passing on 4th attempt on 4th or more attempt is 1 minus the probability of passing on 1st, 2nd, or 3rd attempt. One minus the probability of the first. Right, so the probability of passing on the first is 2 out of 5. The probability of passing on the second, it is still 2 out of 5. And the probability of passing on the third attempt, we've done it. The probability of passing on the third attempt after 3 attempts, it is 2 out of 15. We got 2 out of 15. Okay. Then the probability of passing in 2 attempts, we got 2 out of 5. The probability of passing in 2 attempts, we got 2 out of 5 here. But obviously, the probability of passing first attempt is this, 2 out of 5. The probability of passing in 2 attempts, first attempt is 2 out of 5. 2 attempts is 2 out of 5, we got it before. And the probability of passing 3 attempts is 2 out of 15. In 3 attempts, it's 2 out of 15. How do we know? We did it here, 2 out of 15. 2 out of 15, 3 attempts. All right. So now here we use our calculator, 1 minus. We can take out 15 here. 15 divided by 5, it's 6 plus 6 plus 2. 12, 14 out of 15. And then this is 15 minus 14 divided by 15, which is 1 out of 15. So the probability of the passing in 4 attempts is 1 out of 15. But look, if you have the probability of passing in 4 more attempts, it is 1 out of 15. But this 1 out of 15 is simplified as follows. So it is exactly 1 out of 15. Now use a calculator to check everything here. Let us use a calculator. Let us use a calculator. Let us use a calculator. Let us use a computer. So now a calculator is going to give us 1 divided by 15. What is 1 divided by 15 on the calculator? It is 0.06. 0.06. 0.06666 recurring. So you can write 0.07. So you can then say the probability of 4 of passing, right? The probability of passing, right? Right, the probability of passing on 4th or more attempt is equal to what? We said it's 115, that is what we've got, but it is 0.07. It is 0.07. Any question? Any question about the tree diagram? This one is a tree diagram. Any question?
No, sir.
The tree diagram. No question.
Yes.
Okay, during the week, you need to check your program. We need to have a lesson during the week. But now we might have more. But now it is only if you are free at that time. But you must check your schedule, your work schedule, so that you can know when you are free. If you are not free, it's okay. I'm not saying you need to be free when you are busy. You get the point. But if you happen to be free during the week, it will be very important for you to alert me that I'm free at this time so that I can schedule time with you so that we can practice these things more. Because the exams are coming and we cannot blunder in the exams. We can't falter in the exams. We can't joke with the exams because these results, you're going to use them at university. Because your dream is to go to university, college. You know what you want. I don't know. But your grade 11 results must be good so that when you apply to university, they can give you a place. Because if your results are bad, they will say, ooh, they will just put your report aside. They'll just put your report aside and say, let us check other reports of other students now. Because, we want, what level do we want? We want level 7. That's what we want. We want level 7 from you. But for us to get level 7 from you, we must sweat. We must be sure now if that level 7 is going to come or not. You see? So we can't joke with this. We can't just play with the future like that. So what are you supposed to do? You need to alert me during the week when you have a free time. At least one lesson in the week. We can do more lessons in the week. Our lessons are every day from 6 a.m. If on Saturday you are free in the morning, you alert me that on Saturday I'm free at 6 o'clock. And then we can have the lesson at 8 o'clock on Saturday. But normally I put the lessons at 4 p.m. because not everybody is free in the morning. I'm giving people a chance to go shopping. It's Saturday, they can play, and then they can attend later on at 8 o'clock, or they can attend at 4 p.m. for those who are free at 4 p.m. Okay. So I'll hear from you then, Pekalelo. Okay. You let me know.
Yes, sir.
Okay, thanks, Pekalelo, and goodbye. We shall send you this recording. We shall send you this recording. Okay, so that
Okay, sir.
so that you can watch it during your time, your own spare time. Thanks, Pekalelo, and goodbye.
Bye, sir.
Goodbye.